All right, I guess I get a bonus 15 seconds here. So my name is Jeff Warsinski. Even though it says Grafton Hills, I'm actually an adjunct all over the place and drive all over the place. But mainly my talk today and tomorrow is all about trinomials, because I've been teaching it for a while now and I've never came across a method that I actually was sold on. So the method that I'm actually going to kind of show you today actually has equivalent fractions in it, which looks nothing like factoring whatsoever. So that's actually the one I'm kind of going with now, because I kept going back and forth for different reasons. So that's what I went with. So to start this off, of course, we got our textbook version that we see everywhere that our students see first. And they do this over and over and over and over again. So the main thing is that this method is good, and I'll go into it in a lot more detail tomorrow. But we ourselves as math teachers, we don't like doing this for this specific problem. We find the -3 and the 2, and then we do all this factor by grouping, and it takes a very long time, and eventually once you get further into the courses, you really don't want to do this process. So students even notice, why am I doing this? -3, 2, look, I'm done. And once again, we don't want to teach it, so they catch up on that. We don't want to do it either. So then the problem is you get to this one. The X thing is exactly the same, and then they want to cut corners, and then that's when they do need to do all those steps to actually enforce that the A was different. So this is kind of the main issue that I was seeing, is I picked a method, and then they either did way too much work on short problems, or they didn't do enough work on the longer problems. And they just kept having this issue. So what I was trying to figure out, is there a way to make the short case short and the long case not much different than that one? Because our students like to be lazy. So what we can actually do is we can do an equivalent fraction. We can put a denominator under that thing, and actually that X diagram is exactly the same structure as the other cases. So you're looking for multiply two numbers, get your A to C, add them together, get your B, and I promise I'll show you the proof tomorrow, you do actually get that every single time. So the benefit with this is, for a problem that does have all these different things, you still have to do the X, that's the one downfall. However, you can go directly to that. So you plug in your AX's, you put your A underneath it, you throw your -3 and your 16 in there just like before, and well, we didn't start with a fraction, so we need to get the 8 out of it. Well, how do we do it? We do greatest common factors of those two pairs, and it will guarantee to cancel that denominator every single time. So tomorrow what I'm going to focus on is lots of different methods, this one included, and kind of the pros and cons of everything I've even seen, and some that, well, even like the four-lane method also, so we'll do that one. So notice how concise that is, and then once you get to another one, it is exactly the same thing. So they are writing very little also. They get their X diagram, they plug in their 12s, they plug in their 12 underneath it, so they plug all that in before they even do the X diagram. Once they get those two numbers, well, you can kind of see, in this case, you're going to pull out a 2, you're also going to pull out a 6. Well, if you multiply those two together, notice what that's going to cancel out on the bottom. And also, once you get to like rational expressions and things, they're already taught they have to factor things to cancel things. So they're already kind of getting one step further than they were before. So once again, notice, and we get really lazy with this, this is every single step, detailed. Eventually you start writing very little, and they write very little, which is always a benefit. So this was my main issue again. There's the short case where A was 1 with the same exact X diagram as the longer case. And notice the short case, you put 1s there. Don't need to cancel a fraction, so you're done immediately. The right case, well, you just plug it all into the same exact diagram. However, that one does have greatest common factors. You have to get that 6 out of it, so they know they have to do something. If they can't cancel a 6, they know their X was wrong. And then, well, it's not much longer for that longer case. So really, this is actually 2 topics in every textbook. You can just teach it as one topic, and they don't have to think of when am I doing the shortcut, when am I not doing the shortcut, and they get there immediately. And also, as they keep doing that, they'll actually start developing their FOIL method as they're going. They'll start seeing, why do I want to do the X if I can realize what I'm actually going to end up multiplying together? So tomorrow, that's kind of what I'm going to talk about, a lot more little cases and other methods. But for the most part, when I started, I taught this once this semester already, and it was to glue all these people from elementary algebra together at a certain point in intermediate, and it took about 20 minutes. They hated that first, but they were all at a certain level immediately. So it was very successful. So I'll talk to you tomorrow.